Okay, so in this video we'll be covering transformations of functions, and this includes three main things. So first we have translation, then we have stretching, and then we have reflection. And the fourth thing we'll be covering is composite transformations. So these are the four things that we'll be covering in this video. So let's get started. First we have translation. And for translation, before we start, we should know the general form of a function. And so we know that general form is y equals f of x, right? That's how you would write a function. So in the section of translation, what we're basically doing is moving our graph. We're adjusting it and we're shaping it into something new. So let me draw a small graph on the right. So let's say we have this graph. Okay, and we want to move it. Let's say we want to move it to the right, or we want to move it downwards, or upwards, or to the left, or if we want to stretch it, as in make it like that, then what we have to use are these transformations, right? So the first one is translation, and this applies to when we are changing the function in the form of y equals f of x minus a and f of x plus b. So this one is for horizontal translation. And this one is vertical translation. So basically what this means is if we have f of x minus a where it's inside the bracket, the graph will move a units to the right. If it's negative a, it will move a units to the right. And if we have just a, then the graph will move a units to the left, because it's a minus a. So if you have a negative number, if you want to move it to the left, right? If you want to move it to the left, you would, let's say you have negative 2, x minus minus 2 would be x plus 2. So if you have positive a, that doesn't mean you move to the right, it means you move to the left, because it means you've taken a negative number. And if we have b, then if we have positive b, we move b units upwards, and if we have negative b, we move b units downwards. And that's it for translation. Okay, so we can have a look at this nice visualizer that shows us when we're increasing a, so when it's x plus whatever number, so when we're increasing or decreasing the slider, it's just moving the function by that much to the left or to the right. This can really help you visualize what this translation is doing. Again, similarly, we can look at this visualizer. As we're increasing the value of b, we're just moving the function by that much up or down. So if it's 1.7, it's moved that function from the point where it originally was 1.7 coordinates upwards, and same if we move it 1.6 downwards. Okay, so next we have stretches, and this applies to when we have y equals p times f of x, or y equals f of q times x. Again, this is for vertical stretch, and this is for horizontal stretch. Now, one thing to keep in mind for stretches is that if we're doing a vertical stretch, okay, let's take an example. Let's take an example. So let's say we have y equals 3 times f of x. This means that whatever f of x is will get stretched vertically by a factor of 3. So if this is our function, the new one, it will get stretched by a factor of 3, meaning it will get narrower. So it would kind of be something like this. It would have the same vertex though, because we're not moving that. But this is for vertical. But let's say we have a horizontal stretch, y equals f of 3 times x, then the graph will stretch horizontally by a factor of 1 over 3. So for vertical, it stays the same factor. If it's 3, it's going to stretch by 3. If it's 5, it's going to stretch by 5. But for horizontal, the thing is that it would always stretch by a factor of 1 over that number. And I'll use a visualizer to explain this one to you guys. Now for the stretches, it's the same thing with the visualizer. Let's say I'm decreasing the value of p, and if I keep it to -2, we can see that or -1.9, we can see that the graph has stretched -1.9 times vertically. So this is when we're talking about the vertical stretch. This is when the p-value is, as we can see in the orange text here, is 3.1 multiplied by f of x. So when you multiply it, when it's outside the function, when it's multiplied to the whole function, then it's vertical, and it just multiplies by the scale factor. Now, if we look at our horizontal stretch, we have to be more careful about this, because let's take a look. When we're increasing, let's say we keep q as 2, we can see that the graph has stretched horizontally by 1 over 2. So it stretches by a reciprocal scale factor. So let's say we keep it -2, it's going to stretch by -1/2. And we can see in the orange text here, this is when we multiply directly to x, not the whole function. This is when it stretches horizontally, and we can see over here that if it's -0.37, it's going to get stretched horizontally 1 over -0.37. Okay, so next we have reflections, and this is pretty simple. We can see the graph on the left over here, that the reflection of function y equals f of x is in the x-axis, meaning so if this was the original function, and if it's reflected in the x-axis, which is this, obviously, it's just going to flip, it will flip that way. Or if the original function was like this, then it would have flipped that way. Hope that makes sense. And if we want to reflect in the y-axis, it's basically the opposite. So this was our original function, and we want to flip it in the y-axis, which is this one. So it would flip this way, meaning this curve right here, we can notice the green curve that I just highlighted is the original version of this blue reflected one. So it flipped that way. and it can flip vice versa as well. Okay, so first what we need to talk about is basically composite transformations are when you have two or more transformations within the same function. So if we would have y equal 3 times f of x minus 2 plus 5. So we have 3 out of 4 transformations just in this one function. So composite transformations is basically how you would go about this, and it's pretty much the same thing, but sometimes the order can change your graph. But first let's say we have two translations when transforming. Let's delete this example, and let's say we just have y equals f of x minus 3 plus 2. So this way we have both translations, some units, A units horizontally and B units vertically. So horizontally we have 3 units to the right, and vertically we have 2 units upwards, right? So whatever this function would look like, we would just move it 3 units right and 2 units upwards. But we can write this down in notation form would basically be 3 and 2. So this is called a vector. And when we see this, we know that the graph has to move 3 units to the right and 2 units upwards. So the horizontal shift always goes on top and the vertical shift always goes on the bottom. So yeah, that's basically when we have two transformations, and this is the annotation that we can write it in, just so you guys know if this comes up. I forgot to mention this earlier, but you know to recognize a reflection when you have a negative at the beginning. So if you have a negative 4 f of x plus 3 minus 1/2, this negative indicates that it's going to be a reflection in the x-axis. But if it is, if we have 4 times f of negative x plus 3 minus 1/2, then this means that it will be a reflection in the y-axis. So if the negative is inside, it's y-axis, and if it was outside, then it is the x-axis. And so for composite transformations, let's say we have all 4. Let's say we have negative 4 f of 1/4 x minus 3 plus 3/4. Let's say we have all 4 transformations. Okay, so the order that I usually go with is doing so I do first horizontal translation, then horizontal stretch, then vertical stretch, and vertical translation. So this is the order that I usually go in. I usually leave vertical translation to the absolute last because that one has the least chance of actually changing your whole graph. But again, this may not work 100% of the times, so you need to be careful with knowing the function and knowing whether the horizontal stretch or the vertical stretch will change if you interchange the order that you apply them in. And so that's pretty much it for this video. Thank you.